The question we have today is, does a single 15-minute individual coaching session significantly change students' bowling scores? First, I'm going to calculate the differences. So I'm going to select transform, compute variable. I am going to type diff for the difference, and this is going to be game 1 minus game 2 for the difference. And so now we have a new row right here that shows the difference between game 1 and game 2. Game 1 being the pre-score and game 2 being the post-score after the 15-minute individual coaching session. Now I'm going to see if this is normally distributed. So I'm going to go to Analyze, Descriptive Statistics, Frequencies. I'm going to pull over the difference. I'm going to go to Charts. I am going to choose Histogram and Show Normal Curve. I don't need the frequency table, so I'm going to uncheck that and click OK. So we're going to take a look at this chart. So I see here this chart does not really look normally distributed, but for the sake of the assignment, we're going to keep on. I'm going to go to Analyze, Descriptive Statistics, and Explore. My dependent is going to be the difference, and I'm going to choose Plots. I want a histogram, not a stem and leaf. I do want normality. And I don't want a box plot. I'm going to click Continue. Display the plots. Click OK. Okay, so right here for our Shapiro-Wilk, we have a significance of 0.337. So I can assume normality according to this test. So now I'm going to run a paired t-test. So I'm going to choose Analyze, Compare Means and Proportions, and I'm going to choose a paired samples t-test. And we are going to be comparing game 1 to game 2. Okay. So we are going to look right here first. We've got for game 1 a mean of 90 with a standard deviation of 13.54. Game 2 with a mean of 94.95 with a standard deviation of 14.32. So if I look down here at my significance here is greater than 0.05. Because P is greater than 0.05, we fail to reject the null hypothesis. Looking back up at the mean, the average bowling score increased from 90.00 before coaching to 94.95 after coaching, representing an average improvement of approximately 5.5% following the 15-minute coaching session. To find the percent improvement, I compared students' average bowling score before coaching to their average score after coaching. First, I took the points of how many points that we were increased by subtracting the pre-coaching score from the post-coaching score, and then I divided that increase by the original score and finally multiplied by 100. So that's how I got that 5.5% increase. The purpose of this analysis was to determine whether a 15-minute individual coaching session significantly improved students' bowling scores. Because the same students bowled before and after coaching, a paired samples design was used. Before running the paired t-test, I checked the assumption of normality of the different scores using the Shapiro-Wilk test. The test indicated that the normality assumption was met, so a paired samples t-test was appropriate. Descriptive statistics showed that the average bowling score increased from 90.00 before coaching with a standard deviation of 13.541 to 94.95 after coaching with a standard deviation of 14.318. A paired samples t-test indicated that this increase was not statistically significant, with a t of 19 equaling negative 1.685, a p of 0.108. To evaluate the magnitude of the change, the percentage improvement was calculated. Scores increased by approximately 5.5% following the coaching session. Although scores improve slightly, the large standard deviations indicate considerable variability in students' performance. This suggests that while some students benefited from coaching, the improvement was not consistent enough across all participants to produce a statistically significant effect. Overall, the results indicate that a brief 15-minute coaching session produced a small improvement in bowling scores. The change was not large or consistent enough to be considered statistically significant.